Hello geographers, welcome to this revision video about coastal processes. Within this video we're going to examine the different processes which shape our coastlines, and we can divide those processes into three categories really. We can think about sub-aerial processes, which are processes that operate on the land. That includes things like weathering and mass movement. We can think about marine processes which operate in the sea, which includes various forms of erosion, but also transport and deposition as well. And we also need to be aware of what we call Aeolian processes, which are processes driven by the wind, because that is an important set of processes when we think about things like the formation of sand dunes and perhaps the loss of sediment from the coastal system. We're going to start by considering the important marine processes of erosion. Now, there are different ways in which the waves can erode the rock. Erosion is the breakdown and removal of material by the action of the waves. One of the most common ways this can happen is through hydraulic action. This process occurs really when the power of the waves hitting the cliff face. So we're thinking about the force of the waves crashing into the cliff, and they're going to have an impact on the joints and the bedding planes that exist within the rock. So thinking about the impact of the waves on the cracks and weaknesses which exist within the rock. And when the wave hits the cliff, it will force air and water into the cracks in the rock. What this will do is it will compress those air bubbles, and it will cause them to fizz, or what we call effervesce. So that effervescence, or that fizzing, is building up pressure, and then as the wave recedes, that pressure is released, which creates like a little mini explosion of air and water out of the crack, which is going to loosen the rock. Sometimes you may come across the word cavitation for this process. It's a very similar process to this. And as I've said, rock within the crack is going to be loosened over time, and this process is going to widen those cracks or weaknesses or bedding planes further. So hydraulic action is about the forcing of air in particular into cracks within the rock. Another process that happens when the waves hit the cliff is that they transfer a lot of force and energy to the cliffs as well. We call this wave quarrying or wave pounding. You'll know if you've ever been in the sea when the waves are quite large, how they can quite easily knock you off your feet. There's a lot of energy within those waves. So tall, large, destructive waves hitting a cliff face, they transfer a lot of power onto the cliff face, and that again is going to enlarge cracks or joints in the rock. It's going to perhaps remove large chunks of rock, be able to dislodge boulders through the vibration and the force of the water hitting the cliff, and this is most common perhaps during storms, when we have our largest waves. That's when wave pounding or wave quarrying is going to be at its most intense. Another couple of processes are the processes of corrasion and abrasion. They are quite similar, and sometimes the two words are used interchangeably. This involves rocks being used against the cliff face or against the seabed. So when the waves have quite high energy, they're able to pick up large pieces of sediment. So those high energy waves might be able to pick up pebbles or rocks or boulders, and they're going to be able to throw them at the cliff face. They're going to be able to use those rocks as almost like a tool, if you like, or a bit of ammunition against the cliff face. They're able to throw it at the cliff face, which is going to chip away at it and break it down. The other important role that abrasion has is that the rocks being washed around by the waves have a sort of sandpapering effect. They're able to grind down and smooth down the seabed, and that's particularly important, as we'll see in a future lesson looking at the formation of wave-cut platforms. So corrasion and abrasion are sometimes used interchangeably. Technically, corrosion is when the rocks are thrown at the cliff, and abrasion is where they are dragged over the seabed. An important process which we don't necessarily see happening, but does take place in the form of erosion, is that of solution. This is because the seawater is actually weakly acidic. The salt that is dissolved within the seawater actually gives it slightly acidic characteristics. What that does is it will chemically react with rocks, particularly those sorts of rocks that contain calcium carbonate, rocks like limestone or chalk. Those rocks are particularly susceptible to being broken down through the process of solution, and the rocks are quite literally dissolved away by that chemical reaction. The fifth and final process is the process of attrition. Attrition is where rocks or boulders or pebbles which are already in the sea basically knock into each other or are ground over each other, and that repeating swash and backwash of the waves knocking the pebbles together knocks off the angular edges and makes them become smooth and rounded, and that's why if you think about when you've been to the beach and you look at the stones that are on the beach, they're all nice and rounded and polished because they've been very slowly knocked into each other and have those rough edges smoothed off. What this ultimately does is cause the rock fragments to become smaller as well. So pebbles will become shingle, and shingle will then get ground into sand. So when we think about the sand we find on the beach, a lot of that has come from just the grinding down of pebbles getting smaller and smaller and smaller. So they're the main processes of erosion. And now I want us to think about subaerial processes, which are the processes which are happening out of the sea. We're going to come back to look at some other marine processes a little bit later on. An important subaerial process is that of weathering. Now sometimes people get weathering and erosion confused. So let's just remind ourselves of the definition of what weathering actually is. Weathering is the breakdown or the weakening of rocks at the Earth's surface, what we call in situ. Okay, that basically means without the rocks going anywhere. So weathering makes the rocks weaker. Erosion weakens and removes those rocks. So weathering doesn't cause the rock to go anywhere, it just makes it weaker and makes it disintegrate. Okay, so erosion also removes the material. Weathering can happen in a number of different ways. That rock can be weakened in a number of different ways. And even though the word weather is in the name, actually it doesn't always have to do with the weather conditions. It can be broken down through a series of what we call physical or mechanical processes, chemical processes, or biological processes. So rock can be broken down by one of these three main mechanisms. If we have a look at some examples now of the processes of weathering that particularly operate on the coastline, one prominent feature is what we call salt weathering. This happens when the salt water from the sea, we know the sea is salty, the evaporation of that water leaves behind salt crystals. Those crystals grow and they gradually help to widen cracks in the rock. So this is a type of mechanical or physical weathering. The rock is being physically pushed apart by those salt crystals, and it leaves behind a kind of pitted surface like this. We can see on this boulder these little dimples and dents in the boulder. That's been caused as a result of this salt weathering. Some rocks are also exposed to another physical or mechanical process known as wetting and drying. Certain rocks absorb water, so rocks with quite a high clay content do this. So the absorption of the water makes them expand, and the drying out makes them contract. So as they do that, maybe with rainfall or tides rising and falling, those rocks become weaker. They lose their coherence and their structure, and you can see how the rock on the left hand side here has been cracked as it expands and contracts as a result of that wetting and drying process. A process of weathering you're probably quite familiar with, the process of freeze-thaw action as well. Any water that is in the cracks in the rock as a result of maybe rainfall or spray from the seawater, if the air temperature drops below freezing, that water is going to freeze and it's going to expand. Water expands when it freezes, and that is going to put pressure on the cracks or weaknesses within the rock. And over time, that is going to cause that crack to expand. The water might then melt. It might fill up again and it might expand a bit more. And over time, that rock or crack or weakness is going to be forced apart. So that's the process of freeze-thaw weathering. So all three of those, salt weathering, wetting and drying, and freeze-thaw, they're examples of mechanical or physical weathering. The rock is being mechanically or physically forced apart. We can also have chemical processes. So this is quite similar to the process of solution that we mentioned, which is a marine process of erosion. Same kind of thing can happen with rainwater. So rainwater is also slightly acidic, and as a result of rain falling onto rocks that are particularly susceptible to this, again things like limestone and chalk, those chemicals are going to react with one another. The acid in the rainfall acting with the alkaline in the rocks, producing a chemical reaction. And that's the key thing that makes this a process of chemical weathering. It's a chemical change taking place within the rock. We can also get forms of biological weathering happening along the coastline. It could be that plant roots are growing and expanding in cracks in the rock. That's going to help to force them apart. Even things like seabirds nesting on the cliff or rabbits burrowing into softer material on the cliff can cause it to weaken its structure. And we can also get marine organisms that actually attach themselves and drill themselves into the rocks, like the piddock here that we can see in this photo, this little, almost like a little mollusk that grows on the side of rocks. We can see how it's actually drilled itself into the rock, and again that is going to weaken the structure. So this is all being driven by plants or animals and their action on the rocks. Now ultimately, weathering has to lead to something. Those rocks can't just continue to get weaker and weaker without anything happening. And the thing that happens after they've been weakened is that they are likely to experience some kind of mass movement. Mass movement is the collective term we have for things like rockfalls and landslides and mudflows. So it's worth being aware that mass movement is this collective term that we have, and we can define it as being the often sudden movement of material. I've put often in brackets because more often than not it is a sudden movement, but it can happen quite slowly, as we'll see in a minute. So it's this sudden movement of loose material. It's been loosened by weathering, and then mass movement is going to cause that loose material to move. It's moving down a slope, in this case down a cliff face, really, that's what we're talking about. Okay, so the sudden movement of loose material down a slope or a cliff face, and crucially because of gravity. Gravity is what is pulling that rock onto the beach. So when we look at this example on the left hand side at the top here, this huge rockfall from this cliff, the thing that has pulled that rock onto the beach is nothing more than gravity. Weathering has weakened it to the point where the cliff can't support its own weight, and then gravity pulls that material onto the beach below. Same with this example of a mud flow down here. The rain has saturated the cliffs, and then gravity has caused that mud to flow down onto the beach below. The type of mass movement that we experience on a particular stretch of coastline is going to depend on the type of rock. So whether we have what we call consolidated rock, so for example the hard sandstone cliffs that we can see here, that would be what we would refer to as a consolidated rock, or whether the cliffs are actually made up of looser soil and boulder clay, a bit like the rocks we can see here can see they're not as held together as strongly, are they? It's almost just like the cliffs are made of mud. It's also going to depend a little bit on the angle of the cliff face. So if we have quite vertical, steep cliffs like this, we're more likely to find that things fall off them, whereas if they're more gently sloping, like this one, then things are going to slide or flow down them. So the angle of the slope is important. Also, how saturated the rocks within the cliff are. So if they become full of water, we're likely to experience a different form of mass movement than if those rocks are dry and aren't saturated. Mass movement is a really important input of sediment into the coastal system. So things like rockfalls and landslides, they are providing material that ultimately then gets broken down to become the beach and then perhaps be transported elsewhere by longshore drift. So mass movement is a really important input of sediment into the coastal system, and we've talked about that when we've looked at sediment cells and how mass movement is one of those main inputs of sediment into the coastline. I'd like us now just to examine some of the main processes of mass movement in a little bit more detail. Firstly, we can think about the types of mass movement that happen on consolidated rock. So things like rockfalls and landslides, they tend to happen where the rock is quite solid and it's held together in large chunks. A rockfall happens when literally a block of rock or a loose fragment of rock, like we can see here, this boulder, breaks away from the cliff and quite literally falls onto the beach below. Hence why we call it a rock fall. We've got some rock that's falling. What that does is it creates at the bottom of the cliff large fragments, or even some smaller fragments if it's broken up on the way down, of what we call talus or scree. So if you think about locally the rocks on the beach at West Bay is somewhere that is quite prone to rockfalls, very steep cliffs, large chunks of rock break off the cliff and they fall onto the beach below, just like we can see in this photo here. Okay, we can see all of that talus and that scree that is broken up at the bottom of the cliff there. A landslide is similar in many ways. We're talking about large chunks of rock again, but this time, rather than them falling onto the beach, they are sliding down the cliff face. Notice how the bedding planes of the rock, the layers of rock, are dipped towards the sea, rather than perhaps in the previous example, the layers of rock would be like this. They would be almost horizontal like that. So where they dip towards the sea, where they're angled like that, the layers of rock, that creates the weaknesses which are pointing towards the beach, and therefore we're going to get that rock breaking off and it's going to slide down the cliff face, as we can see here. Again, it might break up on the way down and become kind of broken up into smaller fragments. We can see here how that layer of rock has broken off the cliff and has slid down. Obviously it's broken up on its way down. Places like Lyme Regis, they are quite susceptible to landslides rather than rockfalls because of the way that the layers of rock are angled towards the sea. Some alternative processes of mass movement then. This is likely to occur where we have unconsolidated rock. So in this case, rather than it being a solid rock like sandstone or limestone or chalk, we're talking about cliffs that are essentially made of mud, of sometimes what we call boulder clay or glacial material. So really the cliffs are nothing more than loosely held together soil and stones and gravel. When that material gets wet and becomes saturated, it can move down the cliff in one of two ways. It could move down in the form of a mud flow, so literally the water saturates the cliff, turns the soil into mud, and then that mud flows down the cliff face. like the example that we saw on the slide earlier. I've got another example of it here. You can see how the cliff here is filled up with water. It's turned that cliff material into mud, and then that mud has flowed down onto the beach here. We can see the muddy consistency and appearance of that mass movement here. Alternatively, what might happen is that the saturated soil and rock will sink down the cliff face towards the beach with a bit of a curved motion. Now we call this a slump as well as a rotational slip, and perhaps that word helps us to understand what's going on here. A slump, just like think about slumping into a chair, you have that kind of curved motion, don't you? Imagine if you slumped into your chair, your back would slide down the back of the chair and your bum would slide across the seat of the chair and your legs would slide down onto the floor. That slumping motion is what the cliff is doing. So it's a slide of material, okay, but one with a curved motion. So we can see here how that then produces this kind of stepped appearance in the cliff face. We often see this on areas of the coastline like the Holderness coast in Yorkshire, where there are large areas of unconsolidated rocks next to the sea. When as they become saturated, they slip into the sea with this curved motion. You can see that quite clearly on this picture here. So again, we can trace that kind of stepped appearance of the cliff face as we look down it here, and also you can see that there's kind of been a bit of a curved slide of material, and this grass that's down here would obviously once have been level with the top of the cliff there. If we turn our attention back now to marine processes, the processes that are happening in the sea, you can think about the way in which material is moved around by the waves. And different sized material is moved around by different processes, and it depends a little bit on how much energy the waves have got, but generally speaking we can think about different sized particles being moved in different ways. First of those processes we could have a look at, which happens with the largest pieces of material, is traction. Traction is the rolling or dragging of material along the seabed. So waves aren't necessarily going to have the ability to pick boulders up, but they might have the ability to push them or pull them or drag them along the seabed. So traction refers to that rolling or dragging motion of material along the seabed. Slightly smaller material like stones and pebbles on the beach, they might be able to be picked up, but only maybe for a short period of time, and therefore they might bounce along the seabed in this process that we call saltation. In traction, the pieces of material never leave the seabed, they're just rolled or dragged along it. With saltation, it's almost more like a hopping or bouncing motion of material along the seabed. Even smaller bits of material, like clay or sand possibly, that might be small enough to actually be able to be picked up and carried within the water. When that happens, we call that suspension. The material is suspended within the flow of the water. Another process, which is one that we can't see, is the processes of solution. Shares the same name as the process of erosion, which causes this, but any material that has been dissolved by the seawater, so in this case we're thinking about really tiny particles of minerals that can be dissolved within the water, they're going to be carried by this process of solution. Another important process of transport at the coastline is longshore drift or littoral drift. It's important that you're aware of that other term that we use for this process. So this is the process by which material is moved along the coast, and it could be moved by traction or saltation or suspension. All of those processes we've just talked about could be involved here. Longshore drift is driven by the wind. Very often the prevailing wind approaches the coast at an angle. If we think about the UK, that tends to be from a kind of southwesterly direction. The prevailing wind, remember, that term prevailing refers to the kind of most common or most often direction that the wind approaches. So let's imagine for a moment that our wind is approaching our coastline at an angle like that. What that will mean is that the waves are also approaching at an angle. So our waves are likely to be approaching our beach at the same angle as the wind, because the wind creates the waves. When those waves hit the beach, they're obviously going to move up it, aren't they? And they're going to swash material up the beach. And again, that swash is going to move at the same angle as the wind. So the wind and the waves and the swash are going to move up the beach at the same angle. What will happen though, when that wave runs out of energy, it will flow down the slope of the beach back towards the sea. But it will do that in a straight line because it's being pulled by gravity this time rather than being pushed by the waves. So it doesn't return back the way it came. It goes straight back down the beach, perpendicular to the shoreline, at 90 degrees basically to the coastline, forming this kind of right angle triangle. And that's because it's being driven by gravity. So our backwash comes back at 90 degrees to the shoreline. Another wave then might come in and swash material up the beach, and the backwash again will run straight back down like that. And this process is going to repeat so that material basically zigzags its way along the coastline in the direction of the prevailing wind. So we can think about, in this case, the movement of sediment is going to happen from left to right on our diagram. If we were to follow the position of just one pebble, which maybe started out here, it's going to move up the beach here with the first swash and then back down the beach here with the backwash. The next wave might wash it to here and then backwash it down to this point here. The same thing would then happen all the way along. The pebble would swash and backwash its way along the beach. This is a really important process when we think about the formation of landforms such as spits and bars and tombolos. Another process that we need to consider is the marine process of deposition. Deposition is when the waves drop the sediment that they are carrying. So any time that sand or clay or silt or boulders settle to the bottom of the seabed and are left behind by the waves or the water, that is the process of deposition. It basically occurs when the wave energy is somehow reduced. It's a bit like if you were carrying a really heavy object. When you run out of energy, you want to put that object down. So the marine process of deposition occurs when wave energy is reduced. And that can happen in a number of different situations and a number of different places along coastlines. The most common is perhaps where we have constructive waves, where we have these low energy waves. They haven't got the energy to carry large amounts of material, so much of it will be left deposited on the beach. Particularly where they have quite a strong swash, they're going to help to move material onto the shoreline, onto the beach, but not going to have the energy to remove it. Linked with that are kind of calm weather conditions, where we have low wind speeds, we're going to have small waves, and therefore we're likely to experience deposition happening when the weather conditions are calm. We also experience those calmer weather and sea conditions in sheltered areas of the coastline. So this might be places like a bay, because as a result of wave refraction, the energy of the waves in the bay is less than it is on the headlands. Or perhaps things like spits can act as a barrier to the waves, and the area behind the spit is going to be very sheltered and protected from the oncoming waves and the wind. Can also happen in a river estuary. So that's where the river meets the sea. And that's because the interaction of the river water and the sea water, that encourages deposition to happen. We will look at this a bit more specifically when we look at the formation of salt marshes and mudflats. There's an important interaction between seawater and freshwater and the sediment being brought down by rivers, which can encourage deposition to happen quite quickly in those environments. Final process that we need to be aware of as well, which is maybe not one you would consider when we think about the coast. We often think about the waves doing the work of moving material. We actually need to think about Aeolian processes. Aeolian processes are processes that are wind driven. They're driven by the wind. This is particularly important with the formation of sand dunes because the wind is what is responsible for moving that material up the beach. Now, the wind actually moves the material in a very similar way to the water. So larger particles of sand might sort of bounce along or be dragged along the beach in this process known as surface creep, which is actually almost identical to the process of traction that we talked about earlier. Smaller grains of sand, depending on the speed of the wind, might also be picked up through and sort of bounce or hop along the beach through the process of saltation. That is exactly the same as the pebbles bouncing along the seabed. Even smaller particles might actually be small enough, or the wind might be strong enough to actually pick them up and carry them in the air through the process of suspension. This is particularly prominent after storms. We sometimes see large quantities of sand being blown off the beach quite far inland, and it's an important output of sediment from the coastal system. So in summary then, we've got three different types of processes operating along the coastline. We have marine processes which are occurring in the sea, and that includes processes of erosion and transport and deposition. We have subaerial processes which are happening out of the sea on the land and include things like weathering and mass movement. We have Aeolian processes, which are these processes driven directly by the wind and again responsible for the transport of beach material. All of these processes combine together with other inputs such as the geology to shape the landforms and the landscape that we have at the coastline. And that's what we're going to move on to look at in our next videos. We're going to be considering some of the erosional landforms that we find along the coast.